Hey everyone, I'm Erin Carswell, Foran's VP Exploration, and I'm thrilled to be here with you today to present effectively the bulk of our winter 2024 drilling results into Tesla and the Bridge Zone. Now, some of you will recall we had 6 drill rigs turning on the lake ice this winter between January and April. This enabled us to drill some big, bold step-out holes right along the length of Tesla and really get a better feel for the footprint and the kind of scale that we're dealing with this mineralized zone. Before we leap into it, please press pause on this slide, take a minute to read our disclaimers regarding forward-looking statements. So we'll start off with the wider kind of Flin-Flon greenstone belt view here, and you can see our exploration tenements there in blue on the Saskatchewan side. We'll dip right down, go straight underground here with a view of where we got to with drilling out Tesla and the Bridge Zone at the end of last year. So this is prior to including this year's drilling. You can see McIlvenna Bay with the high drill density there on the right-hand side. The copper and the zinc lenses there are yellow and orange respectively. And I'm just going to highlight Tesla and the Bridge Zone as a bit of a refresher. The Bridge Zone is a structurally complex area that sits in between the two. And then Tesla, I'm just highlighting in blue here. And you can see that it was already kind of shaping up to be quite a significant zone even at the end of last year. And mind you, we only discovered Tesla about 2 years ago, so we've already come quite a long way in understanding this mineralized zone in that time. We'll swing around so that we're looking towards the southwest here, and you may recall that one of the most significant holes that we drilled last year was what we call the Higgs hole, HD 2301, and that was this hole that I'm about to highlight here, which was a big down dip step out hole. What that effectively did for us, it not only extended the down dip, I suppose, lens extent of the Tesla mineralized zone by a couple of 100 meters, but it really gave us the confidence that this was quite a large system that we were looking at, and it gave us the confidence to target it effectively in that way as well. So what we ended up doing, jump onto the next slide to show this, was collaring a bunch of big holes stepping out along the strike of Tesla from the Higgs hole in the down dip orientation, as well as a couple targeting another 200 meters up dip extension from the main Tesla mineralized zone as well. It's probably going to make more sense if I spin this around so you can see the distribution of those holes along the strike length of the body there as well. So some really important holes for us to get a feel for what the scale of Tesla is. I'm just going to zoom into some of the results here, and you will have seen this in the press release. We had some really significant results, particularly TS2420 was one of the best holes we've drilled to date. We've firmed up at least a 500 meter dip extent of Tesla, right from hole 18 in the top of the image here and down through to the hole 20 intersection at the bottom. And the other cool thing about Tesla, of course, is the multiple lenses. And here you can see, again, using hole 20 as an example, just how we get these repeated intersections, particularly towards the central and the northern end of the Tesla zone. Some of these were fantastic grades. I mean, you can see things here, almost 27 meters at 3.67% copper equivalent. We're getting some absolutely beautiful grades out of this stuff, and it doesn't look like these holes or the mineralization is dying out in the down dip. If anything, in some areas it seems to be getting stronger, and we're yet to be able to test the full extent of that. That was the section view. I think what we'll do next is jump back. Now this is looking towards the northeast, so this is coming from the other end of Tesla, and obviously this has McIlvenna Bay and the Bridge Zone turned off for simplicity. But what I wanted to show you was what this drilling has opened up for us now in terms of both infill and in terms of both where we're going to go next, extension drilling. So I'll grab the little tool here, and you can see that obvious areas for infill are going to be in the upper part of the Tesla mineralized lenses there, in between the central zone and the big down dip intersections that we've been getting this winter. And of course, the extension drilling will be continuing to follow the mineralized lenses to depth in that orientation there. So from this drilling, we not only managed to get a better feel for what the possible size is, but we absolutely now have really solid targets, continuing to expand and infill this zone going forward as well. And this is what we're starting to see when we connect the dots a little bit and start to put in some mineralized volumes. These are not resource blocks. We're nowhere near that point yet. What this is looking at the geology, the lithologies, the mineralization styles, even the alteration styles in some cases, and then connecting up what looks to us to be reasonable lenses. And we're starting to see this stacked kind of nature, which is a little bit different to what we see at McIlvenna Bay, where it's a bit of a simpler system with 2 predominant lenses. So at Tesla, we're getting thicker lenses, we're getting more of them. So that's a really interesting observation that we've been able to make off the back of the winter program as well. Just zoom into the next one. This shows the lenses, I suppose, in long section, so you can see the extent. We're getting up around, and I think we announced this in the last press release, we're looking at a little bit over 1 kilometre in strike length at the moment of these lenses, and as I said, at least 500 metres in the down dip orientation. We've got a few of the assay results that we put out in today's release shown on this for you. But what I really like to see is when we put these together with the McIlvenna Bay lenses, we're starting to get a really good feel now for the geometry of the two with respect to each other. So I absolutely love this image. We haven't been able to fill in the bridge zone yet. I mean, you can see we've released another couple of intersections from that area just in this release as well. The structural complexity there still requires a higher drilling density for us to be confident about interpreting mineralized lenses. That will come with time. For the moment, though, it is really interesting that we do seem to keep getting these kind of high-level, higher-grade copper intersections in the bridge zone. We need to understand how those hang together before we can talk more about them, but there's certainly something a little bit different, maybe some remobilization going on there as well. So in terms of what does this mean going forward with our summer drilling in particular, with what we're thinking about doing next winter, most of you will know that Tesla is best drilled from the lake. It dips off towards the northeast, so this is the kind of area that we like to put our drill rigs in order to drill it effectively and hit it at the appropriate angle. So we can't really do that from summer. What we can do, and what we're going to be doing this time, I'm just going to grab a different colour, we're going to be collaring holes in the footwall to Tesla. We're going to be drilling, I suppose, parallel to the body and then using directional drilling techniques to kick up into it to try and hit it perpendicular from the other side. We can only do that for a small part of the mineralized zone. That's really going to allow us to do some of the upper infill areas that we'd identified, but we're certainly really excited about getting into that this summer. And the other thing, of course, we do still have 2 drill rigs on this peninsula over here, and what they're doing is targeting big step-out holes towards the north. Deep step-out holes. Tesla isn't closed out yet, as you can see. We still have a lot of work to do to understand the down dip, the along strike, and also what that means for a potential future resource drill out and beyond. But hopefully you can see that we still have a lot to work with here. It's a super exciting time for us as a company when we talk about bringing our McIlvenna Bay project into development and then what Tesla can add to that as well. So please watch this space. Stay tuned and wish us luck for this summer's drilling. Thanks so much. Bye.